Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be talking about today is notes 14.3, which is over acid and base neutralizations. So go ahead, take a few minutes, and go ahead and answer those bell work questions, then we'll get our lesson started. Alright, now that you've had a chance to answer those bell work questions, let's go over our objectives and our goals for the day. So sub-objective 1 says you need to be able to identify a neutralization reaction. Sub-objective 2, be able to predict the products of a neutralization reaction. And then our goal is be able to calculate the concentration of an unknown acid or base using stoichiometry. Yep, it's stoichiometry time again. So here's what a neutralization is. A neutralization, put very simply, is when an acid and base react with each other. The products of an acid and base reaction are a salt, not NaCl necessarily, but a salt and water. So here is an example of a neutralization reaction. So I know that this is an acid, first of all, because it starts with H. So that means it's an acid. This is HCl, which is a strong acid. Then I know that this, NaOH, is a base because it has OH at the end. Then the products of a neutralization reaction are always water and then a salt. Now what I want you to notice is if I take H and OH, HOH is water. So that's how I get this product. Now if you wanted to, you could write it as HOH. That's fine. The things that are left over, so if I crossed out my OH and I crossed out my H, that's what's left over. That is my Na and my Cl. That's how I get this right here. Don't forget, you have to crisscross your charges if you want to get the right formula for that. Sodium is in the first column, meaning it's a +1 charge. Chlorine is in the 7th column, meaning it forms a -1 charge. So when I crisscross those charges, that gives me 1s as subscripts, but I do not write 1s. So let's look at another example of a neutralization reaction. Here is one that is sulfuric acid reacting with NaOH. Again, how I know that H2SO4 is an acid is because it starts with hydrogen. Then it reacts with the sodium hydroxide. I know that it is a base because it ends in OH. The water is always produced, and the other thing is the salt. Well, to find the salt, all you do is get rid of the OH, get rid of the H, and plug those two together. Now you might ask, like, does it matter which way I write it? Yes, it does. You always write the cation first. The cation is the positively charged ion. So the positively charged ion, the cation, will always be with the base. The negatively charged ion, the anion, will always be with the acid. Okay? So again, this kind of goes along with what I just said. A salt is an ionic compound that's formed from the positive ion of the base and the negative ion, called the anion, of the acid. So here's what I want you guys to do. I've walked through 2 examples with you. I want you guys to try to predict the products of this reaction. Or sorry, I forgot. We needed to balance this equation. Again, the reason why sodium got a 2 behind it is because sulfate is a -2 charge. Then I would balance this. So if we were going to do stoichiometry with it, we would have to make sure that we balance that equation. In your assignments, I will tell you if I want you to balance the reaction or not. So now what I want you guys to do is, I want you to take this reaction right here, and I want you to predict the products of that reaction for me, and then we'll go over the answer. Alright, so now that you've tried that, let's go through what you should have gotten. Well, first of all, HCl is an acid, so I identify that as my acid. I identify calcium hydroxide as my base, so I know that this is a neutralization reaction. Okay? Neutralization reactions always occur between acids and bases, so if I see an acid and I see a base reacting, it's automatically a neutralization reaction. Then I know that what's going to be formed is a salt and water. So one of your products should have been water, the other ones should have been the salt. So the salt is what is left other than the hydroxide and the hydrogen. So that's Ca and that's Cl. So I should put Ca and Cl right here. So I've got my water, I've got my Ca and my Cl, but don't forget, I have to crisscross the charges of my Ca and my Cl. calcium's charge. Calcium's in the second column on the periodic table, so it forms +2 charges. So I need to crisscross my charges in order to get my formula for calcium chloride. All right, that's how. So subobjective 1 says you need to be able to identify neutralizations. Again, how you know it's a neutralization is seeing that it's an acid and a base reacting with each other. Then you need to be able to predict the products of it. How you predict the products is, one of them is always water, the other one is always the salt, and the salt comes from the cation of the base and the anion of the acid. That gives you your salt. Don't forget to crisscross your charges. All right? So, then what we can do is we can then also balance that. Okay, so I would need a 2 in front of my HCl, and I'd also need a 2 in front of my H2O in order to balance my reaction. And again, I would ask you if I wanted you to balance that or not. So, guess what? This is actually going to be good news for you guys. We're going to do stoichiometry, but there's a positive to that. And here's the positive. Acids and bases are solutions, which means you're going to be given molarities and you're going to be given volumes. So what that means is that we don't need to add something new to the mole map. You know how every unit, our mole map has gradually gotten bigger and bigger and bigger. Well, since these are still solutions, we're just going to use the mole map that we used when we did the solutions unit, because we're still using molarities and volumes, so molarity in liters, and we can get to moles. So we don't have to add anything new. So you're still going to have your mole map that looks like this, and that mole map is on the on your notes page for you. Nothing's changed. So basically what our problems are going to kind of look like is we're going to be given the molarity of something, and you'll be given the volume, and you can change the moles. And then you'll be able to change, using the balanced chemical equation, you'll be able to change the moles of B. Then if you're asked to find the volume of something, then you would divide by the molarity, and you'll get to your volume of solution, or you'd be asked to find the molarity of something, and you'd convert to molarity. Okay, that's all we're going to be doing in this unit, is converting between molarity and volume of one thing, and going to molarity or liters, or we can even go to pressure, volume, and temperature, or particles, or grams. Those are all possibilities, but we're going to focus mainly on the molarity and on the volume. All right? So let's look at some stoichiometry problems, and again, really this is just review. All right, so here's what our problem says. It says hydrochloric reacts with potassium hydroxide according to the following reaction. And it gives us that reaction. Again, we know that this is a neutralization because HCl, that's an acid, is reacting with KOH, which is a base. So we should be able to identify, hey, this is a neutralization, this is an acid-base reaction. So here, but that's not what this asks us to do. What it asks us to do is it says, if 15 milliliters of 0.5 molar HCl exactly neutralizes 24 milliliters of KOH solution, what is the concentration of the KOH? So let's look at our mole map. We are given molarity and we are given milliliters of HCl. So if I look at my mole map, I'm given molarity of something, and I'm given liters, or I guess I'm given milliliters, but I can convert that to liters. So technically, if I have molarity of something and I'm given a volume of it, I can convert to moles. Okay? And it asks me, what is the concentration of KOH solution? Well, when it says what's the concentration, it's asking you for molarity. So keep that in mind. We work in, anytime we're doing stoichiometry, we almost always work in molarity in chemistry. So keep that in mind when you're doing your solutions. So I'm going to convert to the molarity of B because that's what it asked me to find, was the concentration of that solution. So, So I'm going to take my molarity, multiply by my volume in liters, that'll get me to moles. Then I'm going to use my B over A conversion, and then I will divide by my liters to get to molarity of B. All right, so let's go through that. So, take my molarity, and again, molarity can be written as moles per liter. So, I have 0.5 moles of HCl for every 1 liter. That's what molarity means, moles for every 1 liter. And I can multiply by this change to liters. Well, remember, hopefully you've learned the quick tricks for changing milliliters to liters by now. I move the decimal point 3 spots to the left to change from milliliters to liters. So I'm going to multiply by 0.015 liters. So now I would be in moles because my liters are going to cancel out. Then I need to multiply by my B over A, my mole ratio. Well, which one was A and which one was B? Well, since I was given molarity of HCl and I was given the volume of the HCl, that means this is A and my KOH is my B. So now I can convert from my HCl to my KOH, but I need that mole ratio and it's B over A. This equation is already balanced. I have one hydrogen, or excuse me, hydrogen here and here, that's 2 hydrogens. I have 1 oxygen on the left and 1 oxygen on the right, and then 1 potassium and 1 chlorine. So it's already balanced, so my mole ratio is going to be, I have 1 mole of KOH for every 1 mole of HCl. So now I would be in moles of B, because if I cancel out my units, my moles of HCl cancel there and there, my liters cancel there and there. So now I would just be in moles of KOH. Well, I need to find the molarity of my solution. So what I'm going to do is it says to divide by liters. Well, I could either just divide that by liters, like probably most of you do. If you wanted to write out the dimensional analysis correctly, you could multiply by 1 over the number of liters I had of B. Well, how many liters did I have of B? Well, it said I had 24 milliliters of my KOH solution. I just need to convert that to liters. Well, the number of liters that is, again, to change milliliters to liters, move the decimal point 3 spots to the left. That would be 0.024 liters. So basically, here's my math. 0.5 times 0.015 divided by 0.024, and that would be the molarity of my solution. And what I get for the molarity of my solution is 0.3125 molar, and again, this would be KOH. That would be the molarity of my potassium hydroxide solution. All right, let's try another. So now it says sulfuric acid reacts with sodium hydroxide according to the following reaction. Again, here's my sodium hydroxide, or excuse me, here's my sodium hydroxide, here's my sulfuric acid. I know that it's a neutralization because there's an acid and a base reacting. Notice that the equation is already balanced for us. So here's what the problem actually asks us to do. It says, if 20 milliliters of 0.4 molar H2SO4 exactly neutralizes 0.5 molar NaOH solution, what's the volume of the NaOH solution required? Well, let's look at our mole map. Again, let's identify what our A and B are. Again, in order to consider something to be substance A, or our known value, we have to be able to change the moles. Since we are given the molarity and the volume of H2SO4, if I know molarity and I know volume, I can change the moles. So that means that makes H2SO4 our substance A. It asked us to find the volume of NaOH. So we're looking for something about NaOH. That would be substance B. So let's look at where we're going to go on our mole map. So we were given molarity and we were given volume of my H2SO4, so I can convert to moles. Then, once I know moles of A, I can use my B over A, my mole ratio, to convert to moles of B. And it asked me in this problem to find the volume of the NaOH solution required. And did it say in what unit? What we're going to do is we're going to pretend that it was requiring it in liters of solution. Okay? So, here's what I'm going to do. Is I would then divide by the molarity of B. That will be the volume of solution in B, and that will be in liters. Remember, anytime you use molarity, the unit of volume that you're going to get, or the unit of volume that you have to use, has to be in liters. So, let's walk through that math. So, whoops, problem. There we go. So, I'm going to take my 0.4, I have 0.4 moles, again, molarity means moles per liter, so I have 0.4 moles of H2SO4 for every 1 liter, and I'm going to multiply by liters, which I was given 20 milliliters of it. I need to change that to liters, which is 0.02 liters. Then I'm going to multiply by my B over A. My B over A is 2 over 1 this time. So I have 2 moles of NaOH for every 1 mole of H2SO4. Then I'm going to change to volume. It says I need to divide by molarity. Now this isn't something that I've talked to you guys about much, but what I'm going to do is, remember how when we did our dimensional analysis, I first introduced it. Remember how you can flip the molar mass in 1 mole and put it on top of each other or on the bottom? So in other words, the molar mass of water, I know that 1 mole of water is equal to 18.02 grams. Remember how I could decide to put 18.02 on the top, or I could put it on the bottom? You can actually do the same thing with molarity. So in the next step on our mole map, it said we needed to divide by molarity. Technically, if I wanted to get to my liters, since the molarity of my NaOH solution is 0.5 molar, it means I have 0.5 moles of NaOH for every 1 liter. I can reverse that. Notice how I put the 0.4 moles of H2SO4, I put the 0.4 moles on top here. Well, I could also flip that. If I want my units to cancel out, I can actually flip these fractions because they're equal to each other. So let me show you how that works out here. Because I have liters on the bottom here and liters here, those will cancel. I have moles of H2SO4 here and moles of H2SO4 here. Those will cancel. I have moles of NaOH here and moles of NaOH here. Those will cancel. The only unit I have left is liters. And it said, what's the volume of NaOH solution? So this would be my liters. So what I'm going to do is take 0.4 times 0.02 times 2 divided by 0.5, and that will be the volume of my solution in liters. And I get 0.032 liters. Now, what if the problem for some reason had said, what's the volume in milliliters? Well, remember, since this is liters, to convert from liters to milliliters, we multiply by 1,000. Another way to do that is move the decimal point 3 spots to the right. Correct? So what I could do is if I move this decimal point 3 spots to the right, that's going to give me 32 and then my decimal point. So if I wanted it in milliliters, that would be 32 milliliters. Okay, so those conversions are pretty easy. You just have to make sure you pay attention to what they ask you to do. So here's what I want you guys to do. I want you to go and try our next question. Go ahead and try that one on your own. The answer will appear on your screen, and that way you can see if you did it right or not. If you have any questions for me, make sure you flag me down. Let me know. I'm happy to help you. And that's it for our video over acid and base neutralizations and stoichiometry. Again, what you should have learned how to do today is you should have learned how to identify neutralization reactions. You should have learned how to predict the products of a neutralization reaction. And you should have learned how to do stoichiometry to find the concentration or the volume of an unknown solution. So thanks for watching.